Auroras, commonly referred to as the Northern Lights, Aurora Borealis, or Southern Lights, Aurora Australis, are stunning natural light displays in Earth's sky, mainly visible in high-latitude regions near the Arctic and Antarctic. These breathtaking illuminations often appear as dynamic curtains, rays, spirals, or flickering lights stretching across the heavens, captivating observers with their vivid and ever-changing patterns. Auroras are caused by disturbances in the Earth's magnetosphere, primarily due to the solar wind. The most dramatic displays occur when the solar wind speed increases, often due to coronal holes or coronal mass ejections from the Sun. These disturbances affect the paths of charged particles, such as electrons and protons, found in the magnetosphere's plasma. As these particles collide with the upper atmosphere, they excite and ionize the atmospheric gases, resulting in the mesmerizing light displays of varying colors and patterns. The appearance of an aurora also depends on the energy imparted to these particles as they are drawn towards the poles. Not just unique to Earth, auroras are also observed on other planets in the solar system, some moons, and even brown dwarfs and comets. The term aurora borealis was coined by Galileo in 1619, blending aurora, the Roman goddess of the dawn, with Boreas, the Greek god of the cold north wind. Auroras occur most frequently in a band known as the auroral zone, which is centered around 67 degrees north and south latitude. This band shifts depending on solar wind pressure, and the region currently displaying an aurora is called the auroral oval. The oval isn't fixed, it moves, pushed by the solar wind about 15 degrees from the geomagnetic pole in the noon direction and up to 23 degrees at midnight. Auroras are most often seen directly overhead within the auroral oval, while in regions farther from the poles, they may appear as greenish glows or faint reds on the horizon, almost like an unusual sunrise. The aurora borealis is visible from northern regions like Alaska, Canada, Iceland, Greenland, and parts of northern Europe, while its southern counterpart, the aurora australis, can be seen from Antarctica, the southern cone, South Africa, and Australasia. Geomagnetic storms, caused by increased solar activity, can expand the auroral ovals, allowing auroras to be seen much farther from the poles. For example, during the Carrington event, the largest recorded geomagnetic storm, auroras were visible even in the tropics. Auroras are dynamic and change with time. They often start as faint glows and may evolve into striking coronas that cover the sky, before gradually fading in reverse order. Historically, it was believed that these changes were due to Earth's rotation relative to a fixed pattern, but research during the International Geophysical Year revealed a global phenomenon called the auroral substorm. These substorms cause quiet arcs to become active displays before returning to a calm state after 1 to 3 hours. Auroras vary in appearance, from subtle horizon glows to grand coronas and curtains. On shorter timescales, auroras can change rapidly, sometimes fluctuating within seconds, as seen in pulsating auroras. These pulsations, with periods ranging from 2 to 20 seconds, are often linked to higher solar wind speeds and cause a decrease in peak emission heights for blue and green auroras. Beyond visible light, auroras also emit radio waves, known as auroral kilometric radiation, AKR, and X-rays, both detectable from space. From early observations by scientists like Elias Loomis and Hermann Fritz, auroras have been recognized as intricately tied to Earth's geomagnetic field. Whether seen from the ground as rays, arcs, or curtains, or from space as poleward arcs and diffuse patches, these natural spectacles continue to fascinate and inspire wonder across cultures and centuries.